a dynamic array in C is basically just, not in C, but a dynamic array in general is just an array that when it reaches its maximum capacity, it reallocates the double the capacity or just multiply it by 1.5. There's like a factor, 1.5 or 2, who cares? But basically that's it. If we run out of space, we double the freaking space using realloc. And if you don't know what realloc is, it's basically like a malloc. Okay, basically you give it, here it is. You give it a, hold on, let me try to highlight it. There it is. So realloc, basically you, rather than just giving it the size like malloc, you give it a pointer and a size. And if that pointer you give it is null, it's gonna act like malloc. And if it's not null, if it's like an actual allocated pointer, then it's just gonna like resize the whole thing, basically. Like, yeah, let's use that. Now, you can have arrays of multiple types, and same thing applies to dynamic arrays. So we can have float dynamic arrays and int dynamic arrays and entity dynamic arrays. But the problem is C does not have generics, nor does it have templates, nor does it have anything related to it. The closest thing we have is macros. When you're writing anything macro related, like anything polymorphism related in C, you better start with a single type. Usually I do integers, and then convert those to macros, so it's like less error prone, so you could like actually debug things. So let's just do that. Let's have a struct int array. Okay, now in int array, we're gonna have the actual elements, and then we're gonna have the count. How many elements do we have in the array, and the allocated, the actual like capacity of the array, like how much space did we allocate for these elements, and how many elements do we have in the array. Okay, now let's make a function array push. Let's actually like push the array. So int array, the actual array pointer, and the value we're gonna push into the array. So the first thing we should check, oh, hold on, let me just prepare a little example here. Do the thing, iterate through the array. So is less than the array count, I increment I, and just printf array equals to percentage d array.elements I. There we go. And let's just push a bunch of things to the array. So we can push like some funny numbers, 6, 7, why not? 69. What have I, oh my god, I messed up my Vim. Okay, 420 and leads. So let's compile this whole thing. And just run main. There we go. Nothing happens because we haven't pushed anything, and array count is equal to 0, so the for loop doesn't do anything. So let's see. First of all, this is 0. So elements right now is a null pointer. If it's a null pointer, then we're gonna allocate, let's say array default capacity, which is like by default 64, let's say, right? So let's just say if the array elements equals to null, then we can allocate those. So array elements equals to malloc size of int multiplied by the array capacity. Okay, let's say array default capacity. Also, before we forget, let's say allocated array default capacity. Let's just do it like that. Now, also, pro tip, instead of using int right here, we can dereference the pointer. We can dereference this. And because the type of this is known at compile time, the compiler will just like get the size of this. So if this is like an element, like an int pointer or a float pointer, it doesn't matter, we're gonna get the size. And yeah, let's just do array elements, array count plus plus equals to value, like actually push. Okay, now the only problem with this, okay, let's make it a bit more readable, like a readability purpose, and just do this instead. So you don't have to be a C programmer to know about this, basically. Also, there's another edge case we're not accounting for is, let's say, the elements, the array elements are allocated, but we don't have enough space. So let's check that. If the array count plus 1 is greater than the freaking array allocated, the capacity, then we're gonna reallocate the whole thing. So allocated, multiply that by like 1.5, multiply by 2, and then realloc the whole thing. So elements equals to realloc. Also for, yeah, like that. So realloc the whole thing and literally just copy this whole thing. Who cares? Instead of default capacity, it's going to be allocated though. There's basically it. So if we just have a bunch of missing includes, so here's going to be stdlib, and here's going to be stddev, or size t, and there we go. It works, but there's only one problem, which is, as you can see, here's some like repeated logic, basically. So instead of mallocing and then reallocate, this is like repetition, I guess. We could store this into a function and call it alloc if null or something, but instead we can just do this, null or, and then here, because if elements are null, if this is like a zero initialized array, then the capacity or the allocated is going to be 0. So multiply that by 2 isn't going to do anything. So what we can do is the following, which is we're going to check if the array capacity equals to 0. If it is, then just set it to the default capacity. Otherwise, just multiply by 2, same result. And now we can put this in an array reserve. No, not an array reserve. More like, I mean, yeah, reserve, that works, why not? No, not value, it's like expected capacity or something. And we can copy all this. And also, instead of this, it's more like expected capacity is greater than what we have allocated. If that's the case, then instead of doing the whole check, we just do expected capacity and we do this. That is basically how it goes. Also, we don't care if the elements are null or not, because reserve is going to do that shit anyway. So let's see. Yep, that looks good. So we could use reserve here, technically. We could use reserve here. So array reserve, we give it the array, and then the array count plus 1. Also, this isn't freaking Jai or Odin, whatever the hell. This is like C, so we gotta do this. My bad. There we go, look at that, dynamic arrays. All that's left now is, first of all, how do you free this? You literally just do this. Elements. Now all we need is, how do we remove elements from arrays, right? So remove, get the array, get the index, right? Let's see. Okay, so let's just do a quick little, cheeky little assert. If we're trying to remove from an empty array, we're kind of fucked. Array count is less than, or not less than, but like equals to 0. No, whoa. Oh, there we go. Now, let's see. There are two ways we can remove an element. First of all, the first one is remove the element at whatever index, and then move each element. So like, let's say, got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And let's just put some space in between each one of these. So the first method is, let's say we want to remove the number 3. Well, what we can do is just remove it, and then get all of these, and just paste them here. Wait, hold on. Get all of these, and just paste them on top of the thing. Paste them on top of it. So we move each element into this. So like we move the 4 here, then move the 5 here, we move the 6, we move the 7, we move the 8, we move the 9, and we get rid of this. Or the other solution, which is what we could do, is when I remove this, I can move the last elements into here. Okay? So one of them is a remove and one of them is an unordered. So one of them is ordered remove and one of them is unordered. Let's start with the, the ordered one. So basically we have the array count. What we can do is we're going to also assert the index. So index is bigger than or equal to 0. No, wait, no, it's gonna be like less than the array counts. Because it's a size T, it's guaranteed to be unsigned, so I'm not gonna do any like below zero checks. All we're gonna do, really, okay, first of all, before I forget, let me just decrement the whole thing by 1. Let's do a mem move. You just move the memory. Array elements at index into array elements index plus 1. Let's just, and then the actual size itself is gonna be, okay, first of all, it's gonna be whatever, and then it's gonna be like size of array elements, like that. And here is gonna be the array counts minus the index. Looks good. Let's actually test it though. So array remove. Anyway, let's remove index 0. Yeah, I forgot to include string. I should include everything in the beginning of the video. Look at that, it works. Well, yeah, it works. I can just remove index 1. And let's test it with the last element. So we got 0, 1, 2, 3, 3, 3. Look at that, it works. Now, how about an unordered remove? This could be like for our entities array where the order doesn't matter, right? So here, instead, let's just say you remove, do the same checks, but here, instead of this, is going to be array count minus 1, and then the array count minus the index. Also, if if the array, if the index equals to array count, then we can return. So basically, if for the unordered remove, we're moving the last element to like the one we want to remove. But if we're trying to delete the last elements, it's kind of pointless to move the last element to the last element. So we can just like decrement the array count and then forget about that. We could also mem set it to 0, but I don't think that's necessary because we use the array count everywhere anyways. So we can just return here. Otherwise, okay, if it's not, otherwise we can just do this. So now let's actually try the unordered remove. So let's just remove 0. So what we should see is leads being all the way up here. Oh god, I messed up the math somewhere. Yeah, it's gonna be like that. I don't think this is correct. Hold on. It's gonna be plus 1. No, hold on. Okay, so we decrement the count. If the index equals to the actual count, which it doesn't, then we return. And then we move the, this is the destination. And here it's the last array element. It's gonna be 1, I think. Okay, nope, absolutely not. I messed up here, hold on. Let me redo this whole thing. So we decrement the array counts. Here it's gonna be array counts minus 1. And why are all of the other ones means? Oh god, no. Yeah, that explains it. Hold on. I do have undo tree, I think, so I should probably just use the undo tree next time, but okay. Look at that, it works. So now if I remove the last element, which is 3, look at that, lead gets deleted. And if I remove like the first elements, then it gets replaced, and I just quit by mistake. Thank you, Tmux. So yeah. Now, here's a problem. We've got our nice dynamic array implementation. We can probably add more, like a pop function or something, or like a push at index function. We can just use mem move and all that. But here's the issue. It only works with the int array. Okay. Now, how do we make this compatible with all types of arrays? Let's say we have like a float array, right? So it's like a float, and here it's a float array. What do we do here? Well, let's turn these into macros, step by step. I'm not gonna do any Vim macro magic, so like this doesn't confuse anybody. Let's just do this. Get rid of these. Do a while statement because we want this to work with if and else statements, and macro expansion kind of goofy. Also, because it's a macro and not a function that takes a pointer, we should also replace all of the dereferencing with like just a normal thing. And last but not least, because it's a macro and the C processor processes, line by line, we have to put, we gotta do a norm. We have to put a backslash, so we tell it that, hey, you, C preprocessor, the array reserve macro, don't stop here. There's a backslash, so go here, 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 here. This is the macro. Instead of just this, it's this. Let's do this for the, and also because of a macro expansion, we should yeah, too time to explain. Let's turn all of these into magical C macros. The best thing to exist. While at it, let me just, yeah, literally just do this. Yep. When you're in the command mode, press Control F to get this really cool menu. You can also use the telescope thing, but I haven't set it to work with visual mode. My bad. Let's just use this. Also, I can just do Control P. It'll just work. And let's do the whole macro thing. So define int array is no longer int array. Same shit here. This is a do while statement. This is a C macro friendly household. You are safe here. Also, each time we look for index, we're gonna surround it by frickin'. I have mini surround, and if I do this, it does some spacing, which is kind of weird, but also I'm gonna ignore it. Yeah, it's kind of weird. Yeah, let's just go to the next one. Add a little thingy. What I could have done this whole freaking time is just do this. Oh my god, I'm so dumb. Anyways, that should, in theory, work. Instead of providing all of these, we can just do this. It should just work. No, it doesn't, because we're doing a return, but this is a do while statement, so we can just do break instead of return. Look at that, it works with every type now. I can just switch this whole thing to a float, go here, and switch this to a float. As I said, here it's like, we're gonna replace this with 0.0, and it just works with like all of. Now this is all good, but one last thing, we don't want to keep track of these types, right? You can technically automate this with a macro, but also you don't want to keep up with types. What if you could just do this and it'll just work? You set the thing to 0 and it'll literally just work. And here, instead of dot count, it's like array count, give the array. Same shit here. You just do this. Like, it's gonna be magical. Also, here's gonna be array free because reasons I'll get into like in a minute. Of course, this is not gonna work, but it would be really nice to have that. Well, that's where what I like to call the STPPS method. STP is, like nothing's single header library, which is the best libraries to ever exist. And one of them is STPDS, stands for data structures. It contains both dynamic arrays and hash map. You might be like, how do they do the whole dynamic array thing where you just give it a pointer and you magically do this? How? Well, basically, instead of all they've done, you know how a struct is like actually ordered and it's just a bunch of memory? Well, instead of doing this, they just put the thing here and they hid it away from you. Literally. Like, they have a struct, they call it array header. So we have the struct array. This is the memory, right? We have array header struct, and then literally next to it in memory, so here, let's do some nice format. And then literally next to it in memory is literally just, your actual data, your elements pointer. That's all we gotta do. So let's just have a header here. So each time we allocate, instead of using this, is gonna be this. Also, we're gonna have an array. We're gonna allocate the header, and we're just gonna plus the size of array header. And then in here, what we can do is say array equals to. Now get ready for some C pointer arithmetic. Basically, you can't just do this, right? If you're like a smartass, you're like, oh man, well, why not just do this? Size of header, or just say array header like that. You might be like, oh yeah, just do that, man, why not? Well, in C arithmetic, pointer arithmetic, I mean, it does it when you do header plus 1, it multiplies that 1 by the size of array header for you. Now the problem is this is an array header pointer, and this is like gonna be an int, float, whatever pointer. So let's just cast this whole thing to a freaking, you know, void pointer. So like it shuts up. And that's basically it. Now instead of array allocated, it's gonna be you know, header allocated. And here instead it's not gonna be realloc anymore. It's more, you know, I think what we might do, okay, yeah, this is kinda interesting because I should check if the array is null, and if it's null, then we allocate this whole thing, but yeah. So this is when we reallocate the whole thing. So how do we get the pointer? Because the header is now like something somewhere. So what we do is say array header equals to array. We're gonna check if the array equals to null, then this equals to null. Else it equals to array minus 1. No, array, yeah, minus 1. This is gonna, and we're gonna cast this whole thing to a pointer like that, and then delete this. So if the array is actually, you know, valid, then if the array is not valid, then header is also not valid, so we can actually like realloc will actually malloc this whole thing. But if it's like pointed to something somewhere, then we can just retrieve our header by decrementing the array pointer by the size of array header. And then we allocate and we set all our things, and then we give you back your array pointer, and all is good. Now let's do the same thing for here, but instead of header counts. Also, let's make some macros here. Array count. Let me give it the array, and all it's going to be equal to is, as I said, it's literally just going to be this. Instead of being a void pointer, so header plus 1. No, wait, it's going to be the array. Cast that shit to the pointer, and then decrement that by 1. Decrement it by 1. And then what we get is a pointer to that, and we can just get the counts, just like that. Also, let's check if the array we have equals to null. If it equals to null, because then if the array equals to null and then we decrement it by 1, we're like dangerous, really dangerous memory territory. Okay, this is like fucked up memory territory. Equals to null, then we just give you 0. Otherwise, we give you the actual count. So here, all I do is say array count, array plus 1, just like that. Here, it's just gonna be the same. Instead of doing the pointer arithmetic twice, what we can do is just say size t or const size t count, which equals to array count of array. Then we pass the whole thing. Oh. Okay, well in that case we could technically make it a macro, but like, sure, I guess. Not a macro, I mean a pointer, oh my god. Yeah, this is pathetic and stupid. We're gonna do pointer arithmetic. Arithmetic, math is fast, guys, trust. Math is fast as fuck. Guys, do not worry about it. We are Gucci. And what I can do is say array, freaking array. Let's have a macro for getting the header, by the way. I don't want to like do the whole points arithmetic thing each time. So we can just say array header, array equals to do the same thing, except we can just return this. And nah, actually let's just, I like to live life dangerously. Let's not do any checks. Header. Yeah, header like that, and then give it the array, and then plus equals 1. And then we want to remove, we do the same thing here. Decrements by 1. So we're sad panda now. Get rid of any occurrence of elements, by the way. So let's just say assert the array is true and the count of the array is greater than 0. And here just have the whole array count. We do the whole index x plus 1 array count, as I said. We give it the array minus the index size of the array. Epic, very epic indeed. Basically apply the same things here. So it's just copy over here. Copy this over here. And here replace every single occurrence of array count with array count array. And also forget about elements, please. Actually, no, dot elements. Just forget about elements. And that should basically be it. So all that's left is to check if our macros are correct, which they're not. We've got some missing backslashes because of the code editing we did. Should be good now. We have some errors. Expected something something, yes. Got a array.allocated, true, true. Let's do the same thing here, but instead of count, it's allocated. So here we can just do allocated array. Same shit here. Actually, no. Hold on. No. Chat, let me cook, chat. Expected capacity. And then what we do here is header. Oh god, no, that's a bad idea. No, absolutely not. What I'm gonna do is just get the frickin' allocated of the array and forget all of that happened. Also, yeah, no more elements, please. Yeah, no more elements. We have more error, guys. Array did no member len. So true, dog. So true. Array free. Yes, we need an array free, which basically just frees the header. So free array header array. Yeah, forgot to do the arguments. Assertion the 0 is less than array count. What the hell do you mean? And the array count is greater than 0. Wait, what line? What line is this? 55? Okay, that doesn't help. Crap. Index 0 is less than the array count. What is the array count? Is 0? When we push. Oh god. Oh my god. Yeah, sure. Yes, just casually, yeah. Invalid next size. Interesting. Multiplied by the size of the array. This is bad because what we should be doing is expected capacity. Oh my god, I'm so dumb. I should have used my brain for half a second. And look at that, it works now. Look at that. We can do all of our array stuff without any more int float array structs. We can just do this. Also, do not. I will post this code on GitHub, but please, for the love of God, don't use it. Instead, go ahead and use STBDS. It is a much more battle tested and stable implementation. So let's look at what they do. Array maybe grow. It checks, maybe grow. If it's null, if it's not null, who cares? And then we do the whole length thing and all of that. It's a much better implementation in my opinion. And they do the same thing. Hold on, they do the same thing. We have like a header struct. Wait, stbds header. Yeah, here it is. Stbds array header. We have the same thing. Well, almost, but still, basically the same. We have our own dynamic array implementation. Never ever dare challenge a C programmer. Anyway, see ya.